Okay, we're looking at examples from IXL Skill I2, and I would recommend the things I write in gray, I highly recommend that you write them too. Now, at IXL, they might give you an expression 9x plus negative 10 plus negative 4. The other way that you could see this would be simplified as 9x minus 10 minus 4. All right, no matter how you look at this, those two numbers, the minus 10 and minus 4, are like terms, and they can be combined. It's a negative 10 minus 4. And so the final answer here would be 9x minus 14. If you subtract 10, and then you subtract 4, you might as well just subtract 14 all at once. Okay, the next example here gives us 3 like terms, all in a row. Right there. Plus 4z minus 10z plus 6z. So what you'll see here is if you add the 4z and the negative 10z, I don't know, any way you look at this, those are all going to cancel out. Maybe I would say if we rearrange this, all right, any way you look at this, you have 10z right here, plus 10z, and then you have a minus 10z. So this is really 2 plus 10z minus 10z, and those plus 10z and minus 10z, those cancel out. Do this. Those add up to 0. So the answer for this one is 2. All right, the next one, I would suggest that you write this. It's negative 10f plus negative 1f plus 6f. You have to recognize that there's a number in front of that f. It's a negative 1. If there's no coefficient in front of f, the coefficient is a 1. And so if we add the first two terms, negative 10f plus negative 1f, that's negative 11f. And then we can add those and get negative 5f. Negative 11 plus 6 is negative 5. So you can use a calculator to double check those. All right, next one. Okay, let me remind you of this. Order of operations, PEMDAS. You have to multiply before you can add or subtract. And so in this expression here, there is multiplication right there. 9 times the quantity 7p plus 4. So we'll use the distributive property first and write this as 63p plus 36 plus 6p. All right. Now, we could rearrange these. We could switch these two terms places. We could switch them and write 63p plus 6p plus 36. You certainly could do that, but I'm going to probably start taking a shortcut here and just underlining that this term here, 63p, and this one here are like terms. And so rather than take the time to write those out, I'm just going to add it in my head. 63 plus 6 is 69. So 69p plus 36. All right, next one is the same situation. But again, a reminder, if you want to write this in, it's a negative 1x plus a negative 3 is kind of like a minus 3. So this is going to require us to use the distributive property. We're going to multiply by a negative 7. And negative 7 times negative 1x is a positive 7x. And then a negative 7 times a negative 3, a negative times a negative is a positive 21. All right, same deal on the next one. There is addition, but watch yourself, because we're not going to add that 7 plus 7 first, even though it's written first. Okay? We have to multiply before we can add. PEMDAS, we multiply before we add. So we're going to use our distributive property here. 7 times 6 is 42. And 7 times 10b would be 70b. And that 7 that was in front, I just wrote it, even though I didn't do anything with it yet. Rewrite the entire expression so that it's still equal to the line above it. And then we can see these two terms are like terms. So we have 49 plus 70b, or 70b plus 49. Okay, on the next page, number 7, I might, yeah, we'll just keep working these out. You can pause the video and try these on your own. But I'm going to try doing this. Start taking some shortcuts. First of all, I'm going to slip a 1 in front of that m. It's a negative 1m. And so I have a 5m plus a negative 1m plus a 7m that are like terms. And then I have a negative 5 plus a negative 8 that are also like terms. If you use this underlining technique to combine your like terms, sometimes that saves you a little time, which students like. So 5m minus 1m is 4m, plus 7m makes this 11m. And then negative 5 plus negative 8 is negative 13. So you could write 11m plus negative 13. I really want to encourage you to recognize that adding a negative 13 is the same as subtracting 13. All right, next one. Again, we can't add anything until we multiply first, so distribute there. I'm going to copy down 8 plus u plus 2 times 9, that's 18, plus 2 times 8u, that's 16u. So here's what we have. Okay, 8 plus u plus 18 plus 16u. Remember, this u has a coefficient of 1. And so my u terms are like terms. And then my 18 and my 8 are like terms. So I'm going to add these together. The 8 plus the 18 total 26 plus 17u. And that would be fine. Or, again, a lot of times putting the variable term first is preferred. So you can write it either way. The next one, okay, we haven't seen this yet. This has variable terms that are squared, 3y squared and a minus 1y squared. So I'm going to do this here. Okay, I'm going to just rearrange these. The 3y squared and the minus 1y squared are like terms. And then we have a plus 2y, and then a minus 7 and a plus 7. So really what we have here are y squared terms that are like terms and constants that are like terms, but that 2y is all by itself. It doesn't go with either of the others. So combining these, 3y squared minus 1y squared, you just subtract the coefficients. 3 minus 1 is 2, so 2y squared. That 2y stays 2y. There aren't any other y terms to combine it with. But a minus 7 and a plus 7 is 0. Negative 7 plus 7 is 0. So those two terms really cancel each other out. Minus 7 plus 7. And the final answer here is 2y squared plus 2y. All right, they start to get a little more complicated here. Again, if you have parentheses in an expression, your first order of business should be to use the distributive property in order to clear away those parentheses so that you can do the addition and subtraction. You have to multiply before you can add and subtract. So first 10 times 8n squared will be 80n squared. 10 times a negative 9n would be a negative 90n. And then negative 6 times negative 6 would be positive 36. And a negative 6 times a minus 4n is like a negative times a negative. That's a positive 24n. So combining our like terms, the only ones that are alike are those two. All right, I'm going to write the n squared term first, 80n squared. But then a negative 90n plus 24n gets us to a negative 66n, and then plus 36. All right, you can use a calculator to find these sums in the products if you're a little rusty on those. Try and do them without, but double check with the calculator. All right, number 8, same deal. We need to distribute and multiply before we can start adding like terms. So 8 times 5b squared would be 40b squared. And then 8 times b. And then recopy. Okay, this is the expression with that distributing completed. Now we see some like terms. The 40b squared plus 3b squared are like terms. They come together to make 43b squared. And the other two terms can't be combined. So just rewrite them, and that's your final expression. Technically, this is all addition, so you could have these added in a different order. But I always like to put the squared term first, then the plain variable term, then the constant term. All right, notice on number 12, they're all x squareds. So we literally just have to do some addition here. 8 plus 5 plus 9 plus 5. All right, add all those up. And that's 13 plus 9 is 22 plus 5 is 27 x squared. Is that right? Yep. 27x squared. All right, next one is a new one. We haven't seen two variables like this yet, but here we have an 8a plus an 8ab plus 3ab. These two terms, because they have the same variables, they're like terms. Same variables and same exponents, technically. So we can combine those. And 8ab plus 3ab would be 11ab. All right, number 14. If you look closely here, I see a cubed b squared, but this one is a cubed b cubed, and another a cubed b cubed. So those two terms are like terms. The first one doesn't change at all, but the like terms can be combined into a single term. 10 minus 2 makes this 8, a cubed b cubed. Last one. These are not like terms. So I'm not sure. Let me look back, see what the instructions said on the other page here. There it is. That's what this instruction is about. If there are no like terms, rewrite the expression, or if you're at IXL, retype the expression. So I'll rewrite this one. But nothing can be combined. It doesn't change a bit. Cannot be simplified. All right, so give IXL a try.